Hey folks, welcome back to another video. Today we're looking at question 1653, minimum deletions to make string balanced. The way we'll be solving this problem is by using a stack. So basically, the reason why we're using a stack is because we can look at characters and delete the most recent character that we pop to a stack to make sure the string is a valid string. And anytime you need to like optimize it with letters and just based on what you've seen previously, it's better to use a stack. So here we'll be using a stack, and there are multiple conditions, right? We know that all of the characters that are given to us are either A or B. So these are the possible conditions that we can come across. Basically, the stack can be empty, and the stack is not empty, right? So when the stack is empty, there are again two conditions that we can come across. Either the letter that we get in the string is A, or we get a letter that is B from the string that's given to us. In either condition, we just add it to the stack, right? We can have a string that starts with A. We can also have a string that starts with B and just goes on to be all B characters for that string. So in this case, we just add it to the stack. In other cases, the other condition is when the stack is not empty, right? And here there are four different conditions that we can come across. The stack has B, and when I say stack, as in like the last character that was popped to the stack has B, and the letter that we come across is A. The stack has A, and the letter that we come across is B. The stack has B, and the letter from the string is B, and the stack is A, and the letter that we get from the string is A. So let's tackle these two conditions first. In both of these conditions, because you're still matching characters, they're valid, so you would just add them to the stack, right? It's basically like a no-op sort of situation. And in this case, if the stack has A and the letter that we get is B, so that is a valid condition as well, because something can go from A to B, like right here, right? So in that case, you also push the letter B to the stack. The only time we need to actually like do something else is when the stack has B, but the letter that we get is A. So in that case, you'll actually pop out this B so that this A can meet other A's if required, and then increment the count. So count is basically keeping a track of how many letters you need to remove. Right, so this is the only thing that we need to take care of. Everything else is basically pushing to the stack. So let's code this up. We need two things. We need int result equals 0. We need a stack, and this is going to store characters. Vector sb, it's just stack st is equal to new stack. Right, and let's get the length as well, and then n equals s dot length. Right, and then in the for loop we iterate through all of the characters. Int I equals 0, I less than n, and then you increment I. And what do you need to do next? So let's check this condition. If stack is not empty, and let's peek if peek is equal to B, and I think it's always lowercase. Yeah, it's either A or B, so it's always lowercase. And let's extract the character here. Character current is equal to s dot character at I, and if current is equal to A, in that case we need to increment the result by 1, and then you need to pop out the stack dot pop, right? Otherwise we just need to push that particular character to the stack. And yeah, And after this for loop is done, you just need to return the result. Actually, that's all we need for this problem. Let's try compiling this. These two test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity of the solution is of n, since we are iterating through every single character in the string. The space complexity is of n, since we're using a stack right here. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I really appreciate that. Thanks so much, and I'll see you folks soon. Peace.